Assalamu alaikum. I hope you're doing well with the distance learning. Today, inshallah, we are going to solve the conservation of momentum assignment. So let's start with the first question. I have 0.16 kilogram cue ball. This one, the cue ball, is traveling at 10 meters per second toward a full rack of 15 billiard balls, these balls together. Okay, I need to find the magnitude of the total momentum of the system, which means all of these balls, 16 balls, 15 plus this cue ball, 16 balls, after the cue ball strikes the rack. Now, as usual, we have to know the given. I have mass, and I have the mass of the cue ball, I have the velocity, and it doesn't matter how many balls do I have. Momentum is always conserved, which means initial momentum and final momentum, they're always equal. How I'm going to find the momentum? All I need to do is just multiply mass times velocity. That's it. So P initial equal P final. I'm going to multiply mass times the velocity, and it will give me this final answer. And of course, don't forget the unit. Mass is kilogram, velocity meter per second. Kilogram times meter per second. Now, the other question. The other question, I have 65 kilogram ice skater, moving to the right, toward this direction. Now, she has or he has a velocity with 2.5 and it throws 0.15 kilogram snowball. So I have actually here two objects. Again, in all momentum, we need to draw the table. We need to specify our objects. And as usual, we have two objects. The first object, which is the ice skater. Second object, the snowball itself. I have to know before and after, before the interaction and after the interaction, or initial and final. Now, mass of the ice skater 65, she will have the same mass in both cases, before and after. Her mass will not change. Now, she's moving with a velocity 2.5. So her velocity 2.5, immediately I can find the momentum before, multiply these two numbers together. So 65 times 2.5, it will give you this amount of momentum, 162.5. Now continue with the question. The mass of the snowball, because kilogram is a unit of mass, 0.15, so I'll write it down here. This is the second object, 0.15, before and after it won't change. Now it's moving to the right with the same velocity. The gears was holding the snowballs, which means both of them actually they're moving with the same velocity. Both of them, they have the same velocity, which is what? 2.5. Immediately I can calculate the momentum, P2, mass times velocity. And I write it down, 0.375. Now we'll continue. Now, after she throw it, this snowball will move with a velocity 32 meters per second relative to the ground. So the velocity of snowball, which is m2, will equal 32. I write it down in the table. Okay, now I need to find what is the velocity of the ice skater. Ice skater is my first object. I don't know what is her final velocity. So V1, because she's the object number one. Final, I don't know. From here, I can continue filling out my table. Mass times velocity, it will give me what? The momentum, which is 65 V1 final. Now, what is the next step after we fill out this table? Yes, we have to apply now the conservation of momentum, which is P initial or P before equal P after or P final. Now, before, you see this column in green, I just look at them because I care only about the momentum. After I fill out of all of this table, I care only about the momentum. So I'm adding before together. This number, I'm adding them together, this and this, add them together. So what do I have? I have 165.5 plus 0.30 0.375 equals momentum after, only look at the green column, the numbers in red. So this is the momentum, 65 times V1 final plus 4.8. Now I have an equation. It's math. I solve this equation and I find V1 final. And I specify since it's positive, so the direction will be what? Will be forward or to the right. Now, third question and the last question. We have a tennis player places 55 kilogram ball machine on a frictionless surface. So I have a ball machine. I have a machine. This machine, this one. This is my first object. This is my first object. This one. And on frictionless surface, as shown below, the machine fires 0.057 kilogram tennis ball. So the ball, it's my second object. So after I specify first object and second object, I start filling out the table. Now, 55 kilogram ball machine, this is the mass of the machine, which is my first object. Before and after, it will be the same, it won't change. Now the machine was stationary with the balls, all of them. So both of them, they will have a velocity 0, which means the momentum initial for both of them, machine and the ball, will be 0. And this is actually what I care about, the momentum, the green column. Now let's come to after now. The machine fires 0.057 kilogram ball. This is the mass of the second object, the ball, horizontally with a velocity 37. So this is the velocity of the ball. I write it down here. And immediately I find out the momentum. Multiply these two numbers together and you will get 2.052. Now I need to know what is the final velocity of the machine. Of course, don't forget the direction. North, it means positive. That's why I put here, I didn't put any sign, it's positive. What is the final velocity of the machine? Machine is object 1, which means I need to calculate V1 final. After I fill out my table, I need to apply what? Conservation of momentum. So I write down the formula, P before equal P after. The momentum before I add only the numbers in green column, the momentum, 0, will equal these two numbers together in the green column. So 55 V1 final plus 2.057. I solve the equation, take this number to the other side, it will become negative and I will get a negative value. Why? Because the ball moves in the opposite direction. 0.037 meter per second. We're done with the assignment. Good luck and have a great day.